The history of conics really illustrates the hand of God and how math comes and goes in our world and what it's used for. So I want to tell you just some brief things about the history of conics. First of all, Apollonius, a Greek man in 262 BC, was the first to really extensively study conics and really get all the information he could about them. The Greeks did a lot of mathematical studies, and it was kind of recreational for them. It was an intellectual hobby for the wealthy and not really put to much practical use except for by the Romans in architecture. Mathematics was actually a product of superstition. Our good friend Pythagoras of the Pythagorean theorem actually worshipped an array of numbers that he called the tetrachys, and it's an array of numbers that looks like this, and each number had a symbolic spiritual meaning, like the number 1 and the number 2 and so forth. A lot of information you could find online about that. He believed also that all numbers were whole numbers or ratios of whole numbers. So unfortunately, his worldview was undone by his own Pythagorean theorem, because in his own theorem he said, we knew that a triangle that has a 1, 1 legs, the right triangle, that this is the square root of 2, which is not a rational number, it's irrational. And legend has it that when one of his followers pointed this out to him, he had the follower thrown overboard as a heretic. I don't know if that's true or not, but at any rate, his own theorem disproved his worldview that all numbers can be written as a ratio of 2 whole numbers. Then we usher in the Dark Ages. There was the fall of Rome. Everything was chaos as far as the governmental systems, a lot of barbarism, a lot of, the civilization as they knew it was destroyed. And in particular, a lot of the learning that had come from the Greeks was lost to the Western world at this time. The big library at Alexandria was burned by Muslims, but many of the Greek texts were taken into the Arab world. The Arabs studied the Greek mathematics, added their own new ideas, like the number system we use now, place value, the idea of zero, solving equations. The word algebra actually comes from an Arabic word. So mathematics didn't fade out entirely, but in the Western European area, there wasn't a lot of math being done. The only pocket of learning was still was in the European monasteries, where they copied Greek texts and they started applying math and science to practical problems that would help the people that they worked with. So their worldview was to subdue the earth for the good of mankind. So they actually developed some simple scientific instruments. Mendel, who was a monk, did some research on genetics, and so there were some things going on, but kind of in isolated pockets in Western Europe. Then in the Middle Ages, the predominant worldview for the planetary motion was that the Earth was in the center. So I'll kind of draw this. Here's the Earth. And because the Earth was where man lived and man was God's crowning creation, the Church in the Middle Ages just believed that everything in the heavens, the sun and the planets, all revolved in circular orbits around the Earth. And this became so strongly held belief that you were considered a heretic to the church if you didn't believe this particular thing about the way planets rotated. However, at this time also, new ideas were coming into the Western Europe. Trade with the Arab world brought Greek mathematics back to Europe, including the idea of the conic sections. Universities were started to start studying some of these ideas as they came back in, and they were called universities because it was believed that all the curriculum was unified under the Christian worldview. In other words, God was the author of all knowledge, so there was a unity to all knowledge, but a diversity of subject matter. And that's what university meant originally. There were improved scientific instruments, such as telescopes, that allowed scientists to gather more accurate data about the universe. Then we have the big conflict that came with the Reformation. Many Christians were very involved in scientific pursuits. As a matter of fact, the Royal Society of England during this time was pretty much the Royal Scientific Society of England was pretty much comprised completely of Christians. So there was no division between Christianity and science. Christians pursued science to the glory of God, and they saw the order of the world as evidence of a creator. But there was a problem. In astronomy, they were gathering a lot of information about planetary motions through the newly developed telescopes and found out that the theory that everything revolves around the Earth in circular orbit did not match the facts of what they were observing as they timed and took measurements about planetary motion. And so some of the scientists, like Copernicus, for example, said the Earth revolves around the sun. He proposed the heliocentric theory that the Earth revolves around the sun based on Greek ideas and the mathematics and the observations from the telescopes. And he was declared a heretic by the church, not because he was not a Christian believer. He was, because he dared to explore science and question the teaching of the church as regards to planetary motion, which was wrong. A man named Kepler, who is kind of the biggie with the conic sections, he's the one that took the knowledge of conic sections, which was discovered way back before the time of Christ, lost for a while to Western Europe, and then came back in just about the time the telescope was invented. Coincidence? I don't think so. He discovered that planets have elliptical orbits, so he was able to take the mathematics that the Greeks had developed and apply it to the newly discovered information about planetary motion. Halley of Halley's Comet, or Halley's Comet, it's usually called, later showed that some comets have parabolic or hyperbolic orbits. So all of the orbits of planetary figures are all conic sections. If that isn't design, I don't know what is. Galileo studied projectile motion, which is all parabolic. Later we have some other people that Descartes, Viète, who are two French mathematicians who came up with the coordinate system and algebraic notation that we use today, which is fairly far, like all this geometry was way long time ago before the time of Christ, but we didn't get XY plane that you could plot points on until like the 1600s. Interesting. Since then, there's been a whole lot of information, so these conic sections have become much more useful in modern world, but we'll talk about that in just a minute. I want to talk a little bit more about Kepler. So who exactly was Kepler and what did he do? So I got to find, let's see, get to my next page. Okay, so here's Kepler. He was a German astronomer and mathematician who lived from 1571 to 1630, and he played a key role in the scientific revolution in the 17th century, contributing a number of scientific breakthroughs, including his famous laws of planetary motion. The first one is that the orbit of every planet is an ellipse with the sun at the focus. And we'll talk about a focus in a minute, but if this is a focus, each ellipse has two foci. So if this is the sun here, and then the Earth's revolving around like this. Then he just said, if you join a line from the sun to the planet, and as the planet moves around, it says the area that is swept out by the planet as it moves is equal areas during equal amounts of time. So if we're over here, okay, to make this an equal area, it's going to have to travel a little farther as it's closer to the sun. So it's going to have to travel faster when it's closer to the sun to sweep out the same area as it does when it's farther. So basically, approaching the sun increases the rate of the orbit, and that makes sense because of gravity. It's being pulled towards the sun, kind of whipped around, and then it slows down, and then speeds up and whips around and slows down. And he discovered that principle. And then the other one is the square of the orbital period of a planet. In other words, the square of the amount of time it takes to revolve around the sun is directly proportional to the cube of the semi-major axis of its orbit. That's this distance right here, if you talk about from the center on out. Another interesting mathematical result just directly derived from conic sections. Kepler was interested in astronomy from an early age, so that's where he kind of got into all of this. He studied philosophy, mathematics, astronomy, and says he even found time to create horoscopes for other students. I've heard different things about horoscopes. I've heard that he created horoscopes because he was required to do so by somebody he was working for, even though he didn't really believe in them. I also heard he believed them. I don't know. He was a Christian believer, though, too. He achieved a lot of his work about the same time Galileo did. They didn't always agree about everything, but they both were very influential in the science and mathematics and philosophy of their time. Kepler's work on planetary motion helped Isaac Newton later devise his own theory of universal gravitation. Now, what's interesting about Kepler is that when he wrote his mathematical works, he would stop in the middle or he will write something mathematical and show formulas and show his calculation, and then just stop and write a hymn of praise to God right in the middle of it. He was very appreciative of the fact that God was revealing his mathematical and scientific wonders to him. And so I have a quote to share with you that talks about how that man being made in the image of God means God has given us the ability to seek out the order that God has put in creation, and that God honors that and delights in that. And this is what Kepler has to say. I considered a right, yes, a duty, to search in cautious manner for the numbers, sizes, and weights, the norms for everything he has created. For he himself has let man take part in the knowledge of these things, and thus, not in a small measure, has set up his image in man. So part of the image, being an image bearer of God, is that we take part in the scientific research of the world God has made. Since he recognized as very good this image which he made, the image of us, he will so much more readily recognize our efforts with the light of this image also to push into the light of knowledge the utilization of the numbers, weights, and sizes which he marked out at creation. So God is allowing us to use the information that he's built in the world for common good. For these secrets are not of the kind whose research should be forbidden, which the Middle Church in the Middle Ages did. Rather, they are set before our eyes like a mirror, so that by examining them we observe to some extent the goodness and wisdom of the Creator. And part of the goodness and wisdom of the Creator is allowing man to discover the mathematics needed to advance the science needed to help better mankind. Technology can be a problem, but can also has done much to make our lives better and easier, and to benefit mankind in many ways. So God has provided the right math at the right time, along with the technology, to fit together to develop theories like what Kepler did with the planetary motion.